Let's take a look on how to identify properties. When we're identifying properties, we have to remember if it is commutative, something's going to be switched. If it's associative, you're going to associate with one group and then associate with another group. If it is identity, you're going to see your reflection. Or, other words, it's going to give itself right back. Okay, let's take a look here. I'm going to highlight certain parts. My first one is 2 times the product of 5 times n equals the product of 2 times 5 times n. I'm going to highlight the parentheses. First thing I want to do, before I highlight the parentheses, did I say the parentheses is the first thing I want to do? I want to check the order. I have a 2 times a 5 times an n, 2 times 5 times n. I know it's not commutative because nothing switched. Okay, and it sends off red highlights because notice I associated the 5 times n and then I associated the 2 times 5. So this would be the multiplication associative property, or the multiplicative associative property. Let's check out the next one. First thing I'm going to do is make sure I have them in order. 42xy, 42yx. Wait a second here. These are switched. And when the same numbers or variables are switched, we're looking at the commutative property. And once again, they're adding, so it's the additive commutative property. Okay. Here, in number 3, I have 3x plus 0 gives me 3x. Notice anytime I add something to 0, I'm going to get the reflection, or whatever it is. 3x equals 3x, which is the identity property. Let's take a look at counterexamples. The whole purpose of a counterexample is to prove something false. How many times do you like to prove your friend wrong, or prove a fact is wrong, even though it's probably a fact? How many times does your parents say the sky is purple and you say no, it's blue, or vice versa? Okay, then counterexamples are for you. You need to prove if it's true or false. When looking at a counterexample, you really need to take a look and see if it's false. So, let's take a look. Let's do an example. And you can pick any example you want. Can I say, and these are just out of the back of my head, 15 divided by 3. Now remember, the commutative property is when the terms switch. So if I'm going to say 15 divided by 3, on the other side, I have to say 3 divided by 15. Well, 15 divided by 3 is 5. Is it equal to 3 divided by 15, or 1/5? No, it's not equal. So here's a statement that or a counterexample that proves this false. Let's take another one. The difference of the 2 different whole numbers is always less than either of the 2 numbers. Take a look at a couple of keywords in order to understand it. And those keywords are, if I can get a yellow one here, difference, which means subtract. We want to subtract two different whole numbers. They have to be different. And we're saying the answer is always less than these two numbers. Well, let's try it out. If I had 6 minus 5, I have the difference in two different whole numbers, equals 1. Is 1 less than 5? Yes. Is 1 less than 6? Yes. That's true. What if I had 10 minus 5 equals 5? Is 5 less than 5? No. Is 5 less than 10? Yes. So in other words, this is false because 5 cannot be 5. So here's a statement that proves it false. Another statement that would prove it false, and there's many of them out there, 20 minus 1 equals 19. Is 19 less than 1? No. Is 19 less than 20? Yes. But what our conjecture is saying is that the 19 our answer has to be less than both whole numbers. So once again, we prove this statement false, or our conjecture. Here's a word problem, to say the least. You can estimate the number of households in a community that own a dog by evaluating the expression C divided by N times P, where N is the number of people per household, C is the population, and P is the fraction of households owning a dog. Suppose these are approximately 2.62 people per household, and 0.365 of the households own a dog. How many households own a dog in a community with a population of 50,000? Basically, what all this information is asking you to do is to test to see if you know the order of operations. We have an expression, Cn divided by P, and they want to know is if I give you the numbers, can you substitute them in for the correct variable? And then can you use your order of operations in order to solve? So step 1, determining what it is. Each variable is. C is the population. P is the fraction of households owning a dog. And N is the number of people per household. So let's go back and write this down. Need a pen to do that. That would help. I want to change. There we go. Okay. So my first one, C, and it says C is the population. And then it tells me N is the number of people per household. And P is the fraction of households owning a dog. Okay, let's go back and see if we can plug in the right information. I'm going to read the rest of the problem. Suppose these are approximately 2.6 people per household. Well, which one is the number of people per household? It's N. So N is going to be 2 and 62 hundredths. And 0.365 of the households own a dog. Remember, P is the amount of people that own a dog. And the question says, how many households own a dog in a community with a population of 50,000? So our population is going to be 50,000. Now we need to take these numbers and plug them into our variables, back into our expression. C is 50,000 divided by N, which is 2.62 or 2 and 62 hundredths, times P, or 0.365 or 365 thousandths. Now this is where order of operations comes in. Even though it says M and then D, or multiplication then division, you have to solve moving left to right. So that means I'm going to solve this first and then multiply it. So in order to do that, 50,000 divided by 2 and 62 hundredths is 19,083 and 97 hundredths. I'm going to round, and now I'm going to multiply by 0.365 or 365 hundredths, and I get 69, or not 6965 or 6,965 and 65 hundredths, which is our answer. And what that tells me is how many households own a dog in a community. If there's 50,000 people in a community, roughly 6,965 or 6,966, if you round up to the whole number, will own a dog.